The number blinked onto the screen at a monitoring station outside Dubai, and for a few seconds, nobody believed it. A wet bulb reading pushing toward the mid-30s Celsius, not standard air temperature. Wet bulb, the kind of figure that isn't supposed to show up in the real world yet. Climate modelers had penciled that in for the year 2070, or maybe 2090. Tucked away in worst-case scenarios most people never read. And here it was. This week, on a Tuesday afternoon, along the coast of the Persian Gulf, a technician double-checked the calibration, because that's what you do when a sensor tells you something impossible. You assume the machine is broken before you assume the planet just crossed a line it wasn't supposed to reach for 2 more generations. The instrument got wiped down, the readings got pulled again, and the log got compared against the station beside it. Same number. Then the next station down the coast. Same range. That's when the quiet in the room changed. Let me back up, because you need to understand what wet bulb actually measures before that figure means anything to you. It isn't the temperature you see on your weather app. It's the temperature a thermometer reads when wrapped in a wet cloth with air blowing across it. Basically, it measures the lowest temperature you can reach through evaporation. Sweat cooling your skin is the human body's entire survival system wrapped up in a single measurement. When wet bulb climbs too high, your sweat stops evaporating. And when your sweat stops evaporating, your body stops cooling down. It doesn't matter how much water you drink, how fit you are, or how much shade you find. Your core temperature climbs, and it simply does not come back down. The theoretical limit for human survival sits around 35 degrees Celsius wet bulb. 35. Cross it for more than a few hours, and a healthy adult sitting completely still in the shade will die. Not from heat stroke in the way you usually picture it, like someone collapsing during a marathon. Just from existing. From breathing hot, saturated air that gives the body no way to dump its own heat. For decades, that number lived in academic papers as a red line on a graph. It was something scientists warned about while pointing at the far end of the century. Dubai just walked right up to it. The person who first flagged this wasn't a government spokesman or a news anchor. It was a researcher watching a live data feed. They're one of a small handful of scientists worldwide who track the Gulf's summer readings, mostly because they've been expecting something like this and dreading it. When the value came through, the immediate reaction wasn't panic. It was doubt. Pure professional doubt. Sensors fail all the time. Cheap weather stations spike. Humidity probes drift out of calibration in the salty air. So the checking began, station against station, hour against hour, and every single cross-reference kept spitting back the same brutal truth. This wasn't a glitch. To understand why that terrified people who study climate for a living, you have to picture where this happened. The Persian Gulf is one of the most dangerous heat traps on Earth. It's a shallow, nearly enclosed body of warm water sitting under a desert sun. The sea surface can hit temperatures you'd expect from a hot tub. That warm water evaporates constantly, loading the air above it with moisture. So you get the desert heat and the ocean's suffocating humidity stacked right on top of each other at the exact same time. Dry desert heat is survivable. Humid desert heat in a coastal city like Dubai or Abu Dhabi is a completely different beast. Roughly 9 million people live in the United Arab Emirates. Across the wider Gulf in Qatar, Bahrain, Eastern Saudi Arabia, and Kuwait, you're talking about tens of millions of human beings clustered along coastlines that are becoming hostile to human life during peak summer. Here's the part that makes the number land even harder. Dubai isn't a fragile place. This is a city that engineered itself out of the sand in a single lifetime. It built the tallest tower on Earth, runs indoor ski slopes when it's 120 degrees outside, and has more air conditioning per person than almost anywhere else. Dubai built itself to prove humans can out-engineer their environment. Money, concrete, refrigeration. If any city on Earth was built to ignore the heat, it's this one. So when a place like that logs a survivability threshold reading, the message isn't just about Dubai. It's about the ceiling. There's a big difference between being uncomfortable and hitting a wall the human body physically cannot climb over. Air conditioning saves you indoors, but millions of workers who build these cities, deliver the food, lay the roads, and keep the whole place running are outside. Many of them are migrant laborers working under a sun that has started producing conditions no amount of hydration can fix. The researchers watching that feed knew all of this instantly. That's why the room went quiet. They weren't looking at a bad afternoon. They were looking at a preview, a date on the calendar that arrived decades ahead of schedule. Showing up in a place with the wealth to shield some of its people and no real way to shield the rest. These readings didn't come out of nowhere. This wasn't a random spike on a broken probe in a parking lot. As the checks piled up, the pattern held across the region under the exact conditions the models always warned about. Bathwater ocean temperatures, a dome of stagnant air, and humidity pinned high through the night so the temperature never dropped enough for anyone to recover. Knowing a thing is coming and watching it actually happen are two totally different experiences. There's a specific kind of dread that hits when a prediction you filed under future suddenly becomes now. The scientists had the graphs, the papers, and the warnings printed in journals almost nobody outside their field ever opened. What they didn't have until this week was proof that the line could be reached this soon, in a real city, right above real people going about their day. So the question hanging in that room, the one nobody could shake as the confirmations kept rolling in, was simple and awful. If that impossible number just showed up decades early, was the sensor lying to them, or was the planet? To get how this works, start with your own body. Your skin sits around 33 degrees Celsius, while your core holds tight to 37. The gap between those two temperatures is the whole secret to staying alive in heat. You sweat, the sweat evaporates. And that evaporation pulls heat off you automatically. It's constant and silent, but it only works if the air around you is dry enough to absorb that moisture. Dry air is thirsty air. It drinks sweat off your skin the second it forms, and every drop that lifts away carries body heat with it. If you step out of a pool in Phoenix, you'll actually shiver in 100-degree heat because the desert air pulls moisture off you so fast. But if you step out of that same pool in a swamp, the water just sits on your skin. That exact difference is what wet bulb measures. To take the reading, you wrap a thermometer bulb in a wet cloth and blow air across it. As water evaporates off the cloth, it cools the bulb down. Just like sweat cools you. In dry air, lots of water evaporates, and the wet bulb reading drops way below the regular air temperature. In soaking wet air, almost nothing evaporates, and the wet bulb number climbs up close to the actual air temperature. So the wet bulb figure isn't the temperature you see on the news. It's the lowest temperature your sweat can cool you down to in that specific air. It is your body's physical ceiling, and that ceiling has a hard limit, 35 degrees Celsius wet bulb, or 95 degrees Fahrenheit. Cross it, and physics stops cooperating. When the wet bulb temperature hits 35, the air is already so saturated and hot that your sweat has nowhere to go. It beads, runs, and drips off you, but it doesn't evaporate. Because it doesn't evaporate, it can't cool you. Your core temperature starts climbing with nothing to stop it. 38, 39, 40, you are literally a pot of water slowly coming to a boil with no way to let the steam out. The part people rarely realize is that fitness doesn't save you here. Youth doesn't save you either. Being an elite athlete buys you almost nothing. A study out of Penn State tested real people in controlled chambers and found the true limit was actually lower than 35, closer to a wet bulb of 31 or 32 for many people, once you account for real human physiology instead of ideal lab equations. Sit a healthy young adult in that air with plenty of water and keep them completely still, and their core temperature marches upward anyway. You have about 6 hours before heat stroke turns fatal, and nobody just sits still in a chair when their city hits that number. They walk to work, wait for a bus, or pour concrete 40 floors up. That's why Dubai is the exact place where a reading like this feels so alarming. Look at where it sits. The Persian Gulf is a shallow, half-enclosed bathtub of seawater, and it's one of the warmest bodies of water on Earth. In late summer, the surface can hit 36 degrees Celsius. Hang a desert sun over that bathwater, and all that moisture evaporates directly into the air. It blows straight inland over Dubai, Abu Dhabi, and Doha. You end up with desert heat and ocean humidity stacked together in the same spot, almost nowhere else combines those two ingredients so aggressively. That geography was always a risky setup. What Dubai did over the last 50 years was lean right into it. Back in 1960, Dubai was a small fishing and pearling town of fewer than 60,000 people. Houses were made of mud brick with wind towers cut into the roofs to catch breezes off the creek. Those wind towers weren't for show. They were survival tech, built by people who knew how dangerous that coast could get. Then oil money arrived, bringing concrete, glass, and rapid growth. Today, over 3.5 million people live among mirrored towers, massive highways, and the tallest building ever made. Every single one of those concrete and glass surfaces traps heat. Asphalt absorbs solar radiation all day and breathes it back out at night, meaning the city never really cools down after dark. Scientists call this the urban heat island effect, and in Dubai, it adds several degrees to nighttime lows. Then there's the air conditioning. Dubai runs almost entirely on AC, which isn't a luxury there, it's life support. But every AC unit works by pumping heat out of a building and dumping it directly into the street. Multiply that by millions of units running at max capacity, and the machines keeping people alive indoors actively bake the air outdoors. The city sweats its own heat into a sky already heavy with Gulf moisture. On top of that, Dubai has spent decades in a non-stop building boom. A huge portion of that labor falls on migrant workers from Pakistan, India, Bangladesh, and Nepal, working outside during the hottest hours. The government imposes a mandatory midday work ban during the summer specifically because people were dying without it. That wet bulb number isn't abstract to those workers. It's the difference between finishing a shift and going to the hospital. When the sensor logged that reading this week, it wasn't measuring empty desert. It was measuring the air right above a city of millions, above traffic, above residential balconies, and above construction sites where crews were working right up until the mandatory break. And it happened early. That's what broke the calm in the monitoring room. A landmark study published in Science Advances back in 2020 by Colin Raymond looked through decades of weather data and found that wet bulb readings near that fatal 35 threshold had already happened briefly in isolated spots around the Gulf. But the models everyone relied on said sustained crossings wouldn't become a regular feature until 2050 or 2070. This week's reading blew right past that timeline. It didn't creep up slowly over decades like the charts said it would. It jumped. That's why the researchers couldn't just accept it and move on. An extreme number arriving this early forces a tough question. Were the models too cautious, or was there something wrong with the equipment? A miscalibrated sensor, a pocket of hot air near an exhaust vent, or a software glitch can easily make things look worse than they are. Sensors drift and report bad data all the time. Before anyone went public saying a major city had brushed against the limits of human survivability, they had to prove whether the instrument was actually telling the truth. The answer came from cross-checking a whole mesh of stations. The coastline reading wasn't just a single outlier, it was backed up by neighboring sensors along the shoreline. Data from aircraft climbing out of Dubai International and humidity gauges miles inland. When investigators pulled the raw numbers, everything lined up. The dew point that morning had climbed above 30 degrees Celsius, while air temperatures sat in the low 40s. Run those inputs through physics, and you get a wet bulb figure scraping 33, hitting 34 in isolated spots near the water. It wasn't a glitch or a phantom reading. It was a real, verified measurement showing conditions where a healthy human sitting in the shade with plenty of water would struggle to cool down. Think about that for a second. A number climate models slated for 2050 or 2070 showed up decades early. To be fair and accurate, a wet bulb reading of 33 or 34 isn't quite the 35 degrees that original studies flagged as the absolute limit. Dubai didn't cross the final line, and it didn't trigger mass casualties in the street. Nobody collapsed in the marina purely because a sensor spiked, and I'm not going to exaggerate what happened for dramatic effect. What actually happened is quieter, but in some ways more concerning. The city showed that the safety buffer is much thinner than we thought. The gap between survivable and dangerous narrowed down to a fraction of a degree. Basically the difference between one humid breeze off the water and the next. Plus, newer research out of places like Loughborough University suggests the real danger line for most people is actually lower than 35. When you test real people instead of ideal physics models, limits drop closer to 31 degrees wet bulb, especially for older adults or anyone with underlying health conditions. That means when Dubai logged that reading, it wasn't just approaching the limit. It likely crossed the safe threshold for delivery drivers, elderly residents, and construction workers pouring concrete under the sun. The line moved toward the city, and the city moved toward the line. What does this mean for the millions of people living in the Gulf? It means air conditioning isn't optional anymore. It's literal life support. About 70% of the region's peak summer electricity goes straight to cooling. If a major blackout or grid failure ever happened during a heat wave like this, the inside of those glass towers would match the outside temperatures within hours. The exact buildings designed to block out the desert become heat traps the moment power cuts out. The defense against the heat relies on the very energy systems driving the warming in the first place. That sensor by the water spat out a value the technician thought was broken. We know now it wasn't a mistake. It was a clear data point showing up decades ahead of where models said it should be. There's a strange irony to where this took place. Dubai is basically built on the idea that humans can survive anywhere. 60 years ago, it was a quiet coastline of fishing villages. Today, it's a metropolis of skyscrapers, indoor ski slopes, and artificial islands. Every square mile of that skyline is a bet that human technology can beat a harsh environment. Most of the time, that bet pays off, but physics doesn't compromise or slow down. It just sends a humid morning off the Gulf, pushes the dew point up a notch, and drives the reading into territory the human body wasn't built for. No alarms sound, and no dramatic disasters unfold immediately. It's just a quiet, verified number saved to a database, showing that the margin of safety is shrinking. Dubai isn't going to disappear tomorrow, and framing it that way misses the point. The real story is subtler. It's a modern city running on massive power grids, built on land that gets harder to live on every year, edging closer to environmental limits. Right now, sensors across the Gulf are still recording data hour after hour. The next time warm, heavy air rolls off the water and the reading spikes, nobody is going to assume the machine is broken. They'll know it's telling the truth.